Okay, so this is the latest weird gizmo that I'm working on. It's a plank of wood. It's not just a plank of wood, it's got a little block on the end and another little block on the end, and between them is a mandolin string. Now, one of the interesting things about mandolin strings, like guitar strings, is they are often made out of metal. In fact, specifically, I've already tested that this is magnetic. Now, I know it's magnetic, but when it's under tension, it's a bit questionable just about how magnetic it is. We look at this end loose lead here, and I bring this motor that's got a magnet inside it close to. Hopefully we can demonstrate some of that magnetism. Don't know if we can. Yes, there we go. So I don't know if you can see that, but you could probably hear it. And if I have the wire contact to the motor and I take the motor away quickly, you get a little clicking noise as it comes off. So this is very slightly magnetic. It's a magnetic wire. So, and it produces a musical note which has some particular frequency, which is the resonant frequency of this string here. As with any stringed instrument, each string has a resonant frequency. Great. I can adjust that resonant frequency here, which is a very ridiculous mechanism at the moment. You loosen off that screw there, twist this until you get the right amount of tension, and tighten it up again, but we will probably develop something a bit more advanced than that. And then I have this gadget. This is the coils taken out of two 24-volt DC relays. So I've cut them and joined them together. So the bit I cut off has all the contacts in it. All right. And they now form two electromagnets. So we just zoom in a bit on those. What you can see here is that normally the armature for the relay would sit in the middle here, or what would be on the end of each one, and operate the contacts. What I've got now is just an air gap. So if I just position this where it's going to end up, which is about here, what we have is about halfway along the string, and the string's got the most movement, with the string around about halfway between the contacts. The theory is that there's one of a number of things I can do here. One is I energize one relay and the string swings towards that relay. Then I switch that relay off and I energize the other relay and the string swings back. And if I do that rapidly with enough current, potentially I could get the string to hammer. I suspect that's not going to work, because I don't think there's the amount of tension in the string required to make a musical sound is so much, so I don't think the magnetism will affect it much. But if I alternate between these two at the resonant frequency of the string, potentially it should resonate and produce a continuous tone. So in other words, I won't have to keep picking the string. I can literally just apply an alternating voltage between these two electromagnets and cause the string to vibrate at its resonant frequency. From there are a couple of possibilities. One is to design a system for fretting this string to get different notes. So to explain fretting, if I take a little wedge here, I put the wedge in and I change the length of the string, the notes it produces is higher pitch for a shorter string. That's called fretting, and I'd need some way to detect which fret it is in order to change the frequency I was putting to the coils. Another possibility might be to pass a current through this wire. So I have a current carrying conductor inside a magnetic field, permanently magnetize these two and produce music by changing the current. Not sure what's going to work here. It's very experimental, but yeah, an interesting concept. There's all kinds of design criteria around how much current I can pass through here, how much magnetism it produces, will it make the string move, are there frequencies that produce particular effects, what happens if I resonate this at an exact multiple of this one's resonant frequency, and then of course the design of a transistor circuit suitable for this, so that any back EMF from these coils won't damage any control circuits. So there's a whole bunch of stuff that's all coming from this plank of wood.